Okay, so we want to talk a little bit about simple machines, but to get to that, we really want to talk about mechanical advantage. So there are six basic kinds of simple machines: the lever, wheel and axle, pulley, incline plane, wedge, and screw. But mechanical advantage is the principle used for all of those simple machines. And it is the ratio of the magnitude of the resistance and the effort force. So the resistance is the load, it's what you're doing the work on. The effort is what you supply, so it's you pushing, in the picture there, the boulder up the hill. All right? Um, it's also a ratio of the distances traveled by the effort and the resistance forces. And you'll notice there in the opposite order, the ratio of the forces is it. We said resistance and effort. Then when we were talking about distance, we said effort and resistance, and it's because they're upside down. So these ratios let us manipulate the variables to either reduce the force required or increase the distance, and change the functionality of different machines and mechanisms. So a mechanical advantage of 4 to 1 tells us what about a mechanism? All right, it tells us about the magnitudes of the force. The effort force is 4 times less than the magnitude of the resistance force. So if you had a 100-pound box you needed to lift, you would only have to supply 25 pounds of force if you had a mechanical advantage of 4. It also tells us something about the distance. It tells us that the effort force travels a distance that's 4 times greater. So if you're looking at the inclined plane, while you might have to lift it up 1 meter straight up, the actual distance, the effort force, so the length of that ramp on top, would actually have to be 4 times greater. So 4 times 1 meter, it'd have to be 4 meters long. All right? So it tells us a couple of things. So let's talk about what work is as defined scientifically. So it is the force applied to an object and the distance traveled. So work is equal to force times distance. And right now we're neglecting friction, okay? So it's just F times D. If you don't make it move anywhere, no work is actually done. It's not that you didn't expend energy, it's not that you didn't try, but no work was done on the object. Right? So as it moves, then that is how we would take that distance, and then the work would be some number other than 0. All right? So the product of the effort force times the distance traveled will be the same regardless of the system mechanical advantage, right? And this was in your Blackboard shell as well, but remember that 1's the magic number. All right, if a mechanical advantage is greater than 1, you need less effort force, but it's a greater distance. If it's less than 1, you need a greater effort force, and it is a shorter effort distance, okay? So the mechanical advantage can never be less than or equal to 0. You should never get a negative number. You should never get a 0. All right? So ideal mechanical advantage is we don't take into account the friction, and it's the ratio of distances, all right? So it's the distance of the effort force divided by the distance of the resistance force. Remember, effort force is what you apply, resistance is the load. The AMA is the ratio of the resistance force to the effort force. So these would actually be measured numbers, and we use these in efficiency calculations. If we are not assuming an ideal situation, the ideal mechanical advantage and the actual mechanical advantage will not be identical. The actual mechanical advantage would be less, right? Because there is friction, there is wind resistance, there are inefficiencies in our world, right? So can you think of something that has a mechanical advantage greater than 1? You could think of all kinds of things. There are windmills, and there are pulley systems, and there are levers, and there are wheels and axles, and all those kinds of things. There's your doorknob, there's the jack, those kinds of things. All right, and can you think of something that has a mechanical advantage of less than 1? You might think of tweezers, you might know that example, but here's the most common one that you interact with probably. Workout equipment. All kinds of workout equipment actually count on a mechanical disadvantage. That way, that's how they actually do the training on them. Alright, so we'll start on levers in the next video.